Good morning and welcome. Learn free at any time. Learn free at any place. Become an eminent scientist, professor, engineer, innovator in the shortest possible time and in the simplest possible way. Let us go through the topic on factorization of polynomials. This is the seventh session in this chapter on polynomials. Keep your books open, that is the NCERT textbook for Standard 9 Mathematics textbook. Plus, you also please keep the plain paper, white paper of size A4 and along with pencil or pen as the case may be, whichever is desired. Keep an instrument box containing the set squares, the scale, the protractor, the divider, the compass, and etc. If you are not good in mathematics, in mental arithmetic, you are welcome to keep a ordinary calculator also. Let us now look at the situation of example 10 above more clearly, more closely. This is what is written in the book in under the chapter factorization of polynomials. If we look at what is that example 10, it is here at the bottom. Check whether the polynomial qt is equal to 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. See, here is the example 10. Check whether the polynomial qt is equal to 4t cube plus 4t square minus 4t minus 1 is a multiple of 2t plus 1. What is important to notice here is in all problems, we are using px or pt or py, etc. we have used earlier. But here, the letter used is q for the name of the function, qt. So earlier, we have reserved qt for identifying the quotient, rt for the remainder, pt for the given function, and gt for the divisor. So what you have to do is the meaning attached to this is not the same as what the problems we did earlier using a general formula like thing where we have used pt for the dividend, gt for the divisor, qt for the quotient, and rt for the remainder. So the question can be asked like this also. Check whether the polynomial qt is equal to 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. Or it can be rewritten as check whether 2t plus 1 is a factor of the polynomial qt is equal to 4t cube plus 4t square minus t minus 1. So let us carry out a long division by using the procedure described earlier. Here, this 4t cube plus 4t square minus t minus 1 is the dividend. 2t plus 1 is the divisor. In this problem, this was represented by the function for polynomial, which is indicated by the letter q and which depends on t. Now, he has also described the quotient that comes here as something like the gt. The remainder is, of course, we can call it as rt, there is no problem. So, our formula becomes pt is equal to 2t plus 1, which is here, that is the divisor, multiplied by the gt, which is the quotient in this problem, plus the rt, which is the remainder here. So pt is the given dividend. So draw a horizontal line like this, and then draw a vertical line also like this. Now inside here, this corner, you write 4t cube plus 4t square minus t and minus 1, which is the dividend. Here you write 2t plus 1, which is the divisor. Now, to carry out the division, what we have to do is, we have to look at what is this first term in the dividend is. This is 4t cube. So, just you have to think about what we have to multiply by this one, what term, so that we get this 40 cube. See, 40 cube is to be divided. We have 2t. Therefore, this is to be multiplied by 2t square. So that 2t square into 2t will become 40 cube. You can also imagine this way. The item to be written here is what is the result of dividing 40 cube by 2t. So if we divide this by 2t, you will get 2t square. So write it here. Now multiply 2t square and this 2t, and you will get 40 cube, which is written here, and then multiply this 2t square by this 1, you will get plus 2t square. Now draw a horizontal line like this, then subtract this one. Now the first term always cancels because we have always selected such that this, whatever we write here, that is 2t square in this problem, when multiplied by with this 2t, the first term there, will always give this one. Therefore, this has to cancel. If it is not cancelling, that only means we have not selected this quotient in a correct way. So we have to redo the problem. Now, remember that when we subtract this term, second term here becomes negative. So subtracting, we will get 2t square. Retain and copy this and write it here as minus t and minus 1. Now repeat the procedure. That is, divide this 2t square by 2t, you will get t. So that t you can write here. Now multiply this t by this 2t to give 2t square, which is written here, and multiply this t by this 1 here to get plus t here. Now draw a horizontal line. Now subtract this 2t square from this 2t square. It will always cancel because of the reason that we have selected the quotient term here such that when multiplied by this first term in the divisor gives this one. So in case it is not cancelling, you have not selected the correct term there. So you have to redo the problem. Now in subtract, this will give minus 2t and copy this minus 1 here. So you'll get minus 2t minus 1. Now, if you divide minus 2t by this first term of the divisor 2t, you will get minus 1. So write minus 1 here and multiply by this, you will get minus 2t right here, and minus 1 into this plus 1 will give minus 1. Now draw a horizontal line here. You see that whatever is this term in the term here, that is minus 2t minus 1, and the 1 what we have to subtract is also the same. Therefore, the result will give 0. So actually, we wanted to make the first term here and first term here to cancel and write whatever that comes here. So in this particular case, this is also automatically getting cancelled, getting 0 as the remainder. Now, the remainder theorem is Pt is equal to 2t plus 1 into gt plus rt, and this rt is 0. Once rt is 0, that only means that this Pt, which is the dividend, is equal to the divisor 2t plus 1 multiplied by the quotient, which is represented in this problem as gt is equal to 2t square plus t minus 1. Now, because of the simple reason that the remainder is 0, we will say that this Pt can be factorized into two factors. One is 2t plus 1 and another is gt. That is, one factor is 2t plus 1 and another factor is 2t square plus 2t minus 1. This can be said in different ways. One is 2t plus 1 and 2t square minus 2t square plus t minus 1. These are the two factors of the given dividend 4t cube plus 4t square minus t and minus 1, or 2t plus 1 is a multiple of that is 4t cube plus 4t square minus t minus 1 is having two roots. One is 2t plus 1, 2t square plus t minus 1 when that is equated to 0, or this 2t plus 1 and 2t square plus t minus 1, they are called the zeros of the polynomial 4t cube plus 4t square minus t minus 1. Or 2t plus 1 is a multiple of 4t cube plus 4t square minus t minus 1. Similarly, 2t square plus 2t minus 1 is a multiple of 4t cube plus 4t square minus t minus 1. So 0 of the polynomial 2t plus 1 is obtained by equating the 2t plus 1 equal to 0, or t is equal to, this 1 will come this side and the 2 will come to the denominator. There will be a minus sign. So t is equal to minus half. So the remainder theorem is q of t is 2 plus 1 into gt plus rt. This is specifically written for this problem because in this problem qt is used for identifying the dividend. 2t plus 1 is the divisor, and gt is the quotient, and rt is the remainder. Now we have found t is equal to minus half, which is called the 0 of the given polynomial qt is equal to 40 cube plus 40 square minus t minus 1. So replace t on both sides by this minus half. So q of minus half is equal to 4 of minus half whole cube plus 4 into minus half whole square minus within bracket minus half minus 1. Now, when we simplify, q of this minus half gives 4 into, see this one, see negative sign is there and power is cube. Therefore, it will give minus 1 by 8 plus this 4 into, this is minus half whole square, that will give positive sign. So therefore, it is 1 by 4 plus this multiplied by minus into minus will give plus, and this will become half. Minus 1 will be here. Now q of minus half is equal to this 8 and 4. We can cancel here, simplify and make it as minus half. This one 4 cancels, so you will get plus 1 plus you will get this half and minus this one. So this minus half and plus half will cancel, and plus 1 and minus 1 will also cancel, giving q of minus half is equal to 0. That means from the remainder theorem, q of t is equal to 2t plus 1 into multiplied by gt plus remainder rt, and the remainder rt is 0, which indicates that 2t plus 1 and this gt, the coefficient, what we got, they are the zeros of the polynomial qt is equal to 40 cube plus 40 square minus t minus 1, are roots of the polynomial equation qt is equal to 40 cube plus 40 square minus t minus 1 equal to 0, or 2t plus 1 is a factor of the given dividend. So the general factorization theorem is, if Px is a polynomial of degree n greater than or equal to 1, and if x minus a is a linear factor of Px, then Pa is equal to 0, where a is a real number. In this example, Pt is equal to 40 cube plus 40 square minus t minus 1 is a polynomial of degree n is equal to 3, and gt, which is the quotient, which is here we are calling it as the divisor, 2t plus 1 is a linear factor of pt. Therefore, equating gt is equal to 2t plus 1 equal to 0 gives 2t is equal to minus 1 and t is equal to minus half. And p of minus half is equal to 0. This indicates that gt is a factor of pt. So here you see we have changed the letter from q to p, which we were using in previous problems, so that pt represents the dividend. And earlier we have used the function gt for representing the divisor. So therefore, that is what we have written here. If Px is a polynomial of degree n greater than or equal to 1, and if x minus a is a factor of x, then Pa is equal to 0, where a is a real number. So this is something like the remainder theorem. The remainder obtained by dividing qt is equal to 40 cube plus 40 square minus t minus 1, which is a polynomial of degree n is equal to 3. In general, this is applicable when n is greater than or equal to 1 by gt, which is the linear divisor. So it's a linear polynomial, 2t plus 1 is 0. Therefore, gt is equal to 2t plus 1 is a factor of qt, which is 40 cube plus 40 square minus t minus 1, which is the dividend. If q minus half, q of minus half is equal to 0, then p is equal to minus half is a root of the polynomial equation qt is equal to 0. Or p is equal to minus half is a 0 of the polynomial qt. And p plus q, that is, take this minus half to the left side, then it will become p plus half. So p plus half is a factor of the polynomial qt, or p plus half is a factor of the polynomial. So we can write the remainder theorem as if Px is a polynomial of degree n, which is greater than or equal to 1, and if x minus a is a factor of Px, then Pa will be 0, where a is a real number. It means that any polynomial which is a function of x, p is a function of x here, which is of degree greater than or equal to 1, and the dividend actually this x minus a, which is a factor of this. When this is equated to 0, we get x is equal to a, and substitute that a for x in the given polynomial, which is value of px when x is equal to a, and simplify. If it comes, it will come 0 if this is a factor. If this is not a factor, this will not be 0, but there will be a remainder. So in stating another way, if Px is a polynomial of degree n greater than or equal to 1, and if Pa is equal to 0, where a is a real number, then x minus a is a factor of Px. So here we are making the same statement in the different way. Here what is said is, if p is a function of x given as a polynomial of degree n greater than or equal to 1, and if when x is substituted by a real number, if the value of this polynomial p of a becomes 0, that only means that x minus a is a factor of px, where this is the general variable used in the given polynomial. This is the particular value, a real number. So if value of the polynomial P at the point x equal to a is 0, then this x minus this a, we can write here as a factor of the polynomial Px. So, which is what is written here. So, if Px is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of Px. That is one statement. So, here it is stated in a different way. That is, if the remainder happens to be equal to 0 or the value of the polynomial equal to 0, then this is a factor. Here it is stated that if the a, the remainder is value of the polynomial x equal to a is found to be 0, then x minus a will be a factor of the given polynomial, which is a function of p as a function of x. By remainder theorem, Px, we can write it as x minus a into qx plus Pa. So, here we have used earlier also Px. So, P is a function of x and it is x minus a is the dividend divisor and qx is the quotient and this is the remainder, particularly when x is equal to a. So, in this function, if x is replaced by a, naturally a minus a becomes 0 and therefore Pa is already 0. So, this totally this becomes 0. If Pa is equal to 0, then Px is x minus a into Qx, which shows that x minus a is a factor of Px. Since x minus a is a factor of Px, Px is equal to x minus a into Gx for the same polynomial Gx. In this case, Pa is equal to a minus a and Ga will be 0. Now, let us examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus c. So, here we can do this by two different methods. One is by dividing this dividend by this divisor, finding the remainder. Then if remainder is 0, then this x plus 2 is a factor. Alternatively, we can make this equal to 0, that is x plus 2 is equal to 0, therefore x is equal to minus 2. So, the 0 of x plus 2 becomes minus 2. So, let Px is equal to x cube plus 3x square plus 5x plus 6. Now, replace every x here by this minus 2 and simplify. Say minus 2 here, cube will be minus 8, minus 2 square here will give the 4. 4 into 3 will be 12 and minus 2 into 5 will be minus 10 and this is 6. So, here we got 8, this is minus 8 and this is plus 12. So, we got 4 and this is minus 10. So, we get minus 6 and this is plus 6 will be 0. That shows that x plus 2 is a factor of the given polynomial x cube plus 3x square plus 5x plus 6. So, remainder theorem is Px is equal to Gx into Qx plus Rx. If Rx is 0, then Px is equal to Gx into Qx. So Gx and Qx are factors of Px, or Gx is multiple of the Px is multiple of Gx, and also Px is multiple of Qx, or Gx and Px are the roots of the polynomial equation P of x is equal to 0. If Gx is equal to x minus a, then Px can be written as x minus a into Qx because the remainder is 0. If x is equal to a, then Pa is equal to a minus a into Qx is equal to 0. So this proves the remainder theorem. So Px is equal to Gx into Qx plus Rx. If Rx, that is the remainder, is 0, then Gx and Qx are factors of polynomial Px. Or Px is equal to Gx into Qx plus Rx. If Rx is equal to 0, then Gx and Qx are factors of polynomial equation Px is equal to 0. So here, that example he has worked in the book and the answer is 0. So important thing is, in the examples, although the answers and the procedure is given, while solving, you try to see whether you can do it on your own without referring to the book, using whatever you have learned. If you cannot, or to check the answer, refer to the example that is worked out in the book. This will indicate either you are wrong or what is printed in the book is wrong. So you'll be able to correct yourself if you are wrong, because the important thing is, when performing addition, subtraction, multiplication, division, or powers, or calculating roots, it is necessary to take care of the positive and the negative sign of the operands, as well as the result of multiplying, adding, subtracting, or dividing signs by giving importance to the plus or minus sign of the individual items or terms. By the factor theorem, x plus 2 is a factor of x cube plus 3x plus 5x plus 6, because we found the value of the polynomial x cube plus 3x square plus 5x plus 6 at the point x is equal to minus 2, which is obtained by equating x plus 2 is equal to 0, has given the remainder or the value as 0. Same thing, the second problem. So here, this is another problem. So actually in one problem, there is a two in one problem. See, first is we examine whether x plus 2 is a factor of this. And second problem, we'll examine whether 2x plus 4 is a factor of this. So here we can see this 2x plus 4, we can take two common factor and write it as 2 into x plus 2, which indicates that since already we have found x plus 2 as a factor of the given polynomial, 2 into x plus 2 also the factor. That means 2x plus 4 is also a factor. But however, we can make it 2x plus 4 is equal to 0. So we'll get x is equal to minus 4 by 2 or minus 2. And since s of minus 2 we have already worked out, which is equal to 2 into minus 2, in this case, plus 4 equal to 0. So therefore, we find that x plus 2 is a factor of 2x plus 4, and also x plus 2 is a factor of the given polynomial x cube plus 3x square plus 5x plus 6. Now consider another example. Find the value of k if x minus 1 is a factor of the polynomial 4x cube plus 3x square minus 4x plus k, where k is to be determined. It is not given. So what exactly we will do? Since it is given that x minus 1 is a factor of the given polynomial, we find that equating x minus 1 equal to 0, we get x is equal to 1. So calculating the value of the polynomial at x is equal to 1 is written as p of 1. So that means replace x in the polynomial by the value 1. So p of 1 will give 4 into 1 cube here plus x 3 into 1 square minus 4 into 1 plus k. We know that since x minus 1 is a factor of the given polynomial, this value of the polynomial at x is equal to 1 should be 0. So we write that one there. Now simplify this, make it equal to 0 so that we can find the k, which is the only unknown. So here, look at this bracket that has been used. So whatever you are substituting, please see that whether it is plus sign or minus sign, it is properly written there. Generally, positive sign is not written and unsigned numbers are treated as positive. Now, if it is negative, it is necessary to mention here minus 1, minus 1, minus 1 within the bracket, so that when simplifying, we'll take care of the signs and make the calculations correctly. So here, since we have substituted plus 1, there is not much confusion at all. So this will give 4 into 1, which is 4, 3 into 1, which will be 3, minus 4 into 1 is minus 4, plus k will be k. This should be 0. So 4 and minus 4 will cancel. 3 when come to that side becomes minus 3. So k becomes minus 3. So we can say the value of k is minus 3 when x minus 1 is a factor of the given polynomial 4x cubed plus 3x square minus 4x and plus k. This k has to be minus 3. So that is what is worked here. We will now use the factor theorem to factorize some polynomials of degree 2 and degree 3. We have already become familiar with the factorization of quadratic polynomial. Example, x square plus lx plus m. The factorizing can be done either by splitting the middle term, that is lx, which is the second term or the middle term here, as ax plus bx, two terms, so that the product AB will become m and sum of a plus b becomes l. So x square plus lx plus m can be written as x plus a into x plus b. So let us factorize the quadratic polynomial of the standard form ax square plus bx plus c, where a is not 0 because if a becomes 0, this term will not be will be present, will be absent, and the polynomial becomes a linear polynomial bx plus c because it doesn't have the term containing second degree of x. A, B, C's are constants. So this remains as quadratic polynomial if B is 0 or if C is 0 or both B and C are 0, but A should not be 0. If B and C are 0, it is called as a monomial. Factorization of the polynomial ax square plus bx plus c is done by splitting the middle term as follows. One is, here we are trying to do something like a derivation of the method. Let the factors be px plus q and rx plus s. If these two are the factors of the given quadratic polynomial ax square plus bx plus c, then we can write ax square plus bx plus c is equal to the product of these two, px plus q and rx plus s. So these two, when we multiply and simplify, it comes like this. So that we will check the step-by-step procedure. So let ax square plus bx plus c is equal to px plus q multiplied by rx plus s. Then this ax square plus bx plus c become equal to, now multiply px with rx, you will get px rx plus multiply px with s, you will get px s, then q with rsx, you get qrx, then q with s, you will get qs. Now here, this x into x becomes x square, so we can write pr into x square. Here x you can take common factor, you will get ps plus qr into x, and this qx will be there. So this one in standard form is ax square plus bx plus c. Compare the coefficients of ax square plus bx plus c and pr into x square plus ps into qr, ps plus qr into x and qx. You can see that c is equal to this qs, a is equal to pr, b is ps plus qr. So which is written here, a is equal to pr, b is equal to ps plus qr, and c is equal to qs. Now if we multiply ps into qr, we get pr into qs, that is ps into qr can be also written as pr into qs. When you write like that, this pr into qs will give the product a into c. So a is pr and c is qx. So it is ac. That is ps and qr or pr qx, they become the product a into c. So that is what is written here. So it is pr into x square plus px ps plus qr into x plus qs. Comparing the coefficients, we get b is equal to ps plus qr and c is equal to qs. This shows that b is, that is the second coefficient of the second term in the quadrilateral in the standard form, that is ax square plus bx plus c, is the sum of the two numbers ps qr, whose product is equal to ac. Therefore, for factorizing ax square plus bx plus c, we have to write b as sum of two numbers whose product is ac. So let us work out a problem to make this point more clear by solving this problem. So the example is factorize 6x square plus 17x plus 5 by splitting the middle term. This is given in the problem using this method only, and by using the factor theorem. So first we will split and then we will use the factor theorem method also. So first method is by splitting the middle term method. Now splitting the middle term means we have to find what are the two numbers, say for example P and Q, such that if you multiply PQ, we should get 5, and when we add P and Q, we should get 17. So P plus Q should be 17 and PQ must be the product 6 into 5. So that is 30. So coefficient of x square and the constant term are multiplied to get the product of the two terms which are split, which are the two terms obtained by splitting the middle term here, 17x. So if P plus Q is 17 and PQ is equal to the 6 into 5, which is equal to 30, then it is easy to find the factors. So P is here a function of x. So 6x square plus 17x plus 5 is the given polynomial. Split the 17 into two factors such that the product is 6 into 5. See, this coefficient of x square and constant term are multiplied to get the product of the two terms. And sum is 17. The factors of 30 are, now we can write this 30, what are the different factors we can think of? One is, we can say 30 can be written as 1 into 30, or 2 into 15, or 3 into 10, or 5 into 6. Of course, continuing, you can get 6 into 5, 10 into 3, 15 into 2, and 30 into 1 also. But they are same as this one, because 1 into 30 is same as 30 into 1. 2 into 15 is same as 15 into 2. 3 into 10 is same as 10 into 3. And 5 into 6 is same as 6 into 5. Now, among these four, we have to select those numbers whose sum becomes equal to 17. Now, this will give, sum will give 31. The sum of these two gives 17. Sum of these two will give 13. Sum of these two will give 11. So we have to select 2 and 17 as the numbers. Now select 17 is equal to 2 plus 15, because 2 into 15 gives that 30, product 36 into 30. And adding 2 plus 15 gives 17. Now here, once we get these numbers, this given polynomial, we can write it as 6x square plus, instead of 17x, we can write 2 plus 15 into x plus this 5. Now it is equal to, removing this bracket, we get 6x square plus 2 into x we write here, plus 15 into x we write here, plus 5. Now the polynomial becomes 2x. That is, here we are taking this 2x as the common factor, leaving here 3x and leaving here 1. Plus, here we will take 5 as the common factor. That gives 3x for this term and 1 for here. So, it can be written as taking this 3x plus 1 and 3x plus 1 as common factor. We get 3x plus 1 into this 2x here and plus 5, which is written there. So, this means the given quadratic polynomial 6x square plus 17x plus 5 is written or factorized in the form px is equal to 3x plus 1 into 2x plus 5, which are the two linear factors of the given polynomial. It can also be done like this, that is, given polynomial, which is a function of x, say px is 6x square plus 17x plus 5. Now here, suppose we try to take 6 as the common factor, then you get x square here, plus here you will get 17x divided by 6, plus here you will get 5 divided by 6. Now, if a and b are zeros of this polynomial px, then px is equal to, we can write it as 6 into, this is x minus a into x minus b for this item here. And the product AB must be equal to 5 by 6, that is given there. So what are the different factors of 5 by 6? So here we can write like this 6 can be written as 1 into 6 or 2 into 3. Now the 2 and 3 are written here, and numerator we can keep 1. Next time, keeping the numerator 5, the factors 2 and 3 are written there. So the factors of 6 are, it can be written as 1 into 6, 2 into 3, 3 into 2. So here 1 into 6 is not suitable for giving us the result. Therefore, it is not considered. Now, among these, if you select these two, then you see when we multiply these two, we get this 5 by 6, because 3 to 2, that will become 6. And if we add them, then LCM is 6. Here you will get 2, and here you will get 15. That means it is 17 by 6. So the given polynomial, with taking out the 6's common factor, we can write it as x square plus 1 by 3x plus 5 by 2x. That is, we have taken this middle two term, which are giving the required value, and plus this 5 by 6. So you have to write a plus sign here. Now px is equal to 6. Now between these first two terms, takes x as the common factor, you will get x plus 1 by 3, plus here you take 5 by 2 as the common factor to get x plus 1 by 3. Now take x plus 1 by 3 as the common factor, the other factor becomes x plus 5 by 2. So finally px can be written like this. So px, we can write it this way. Now substituting, making this equal to 0, you get minus 1 by 3. Substitute here and find the value of px when x is equal to minus 1 by 3. We find that this minus this will always give 0. So 0 into anything will be 0. So we get 0. Similarly, equating x plus 5 by 2 equal to 0, you get x is equal to minus 5 by 2. So P of minus 5 by 2 is equal to 6 into x plus 1 by 3. Now here we have not substituted minus 5 by 2 because once you substitute here, this becomes 0 and this into whatever is here will become 0. Therefore, that way. Otherwise, we can substitute here also minus 5 by 2, but there is no need to simplify this one because this term is giving 0. So x plus 1 by 3 and x plus 5 by 2 are factors of the given polynomial Px. So that is what exactly worked out here. So the polynomial, the terms selected are p plus q is 17 and pq is equal to 30. So it is written here. Only thing is all the steps are not written. So here we have written 2x plus 15x. Here it is written after taking x as the common factor. Now, see, taking 2x as common factor, we get 3x plus 1. Taking 5 as common factor, you will get 3x plus 1. So 3x plus 1 multiplied by 2x plus 5. These are the two factors. Now, same thing we can do using factor theorem also. This what you have done is by splitting the middle term into two parts such that the two numbers are sum of them equal to the middle term, and product of that is same as product of this A into C. So factor theorem means we can write it taking the 6 common factor. Now this 17 by 6 we have to split into two numbers. So if you write like this, then we get product is equal to 6 by 5 because we have made the coefficient here is 1. So 1 multiplied by 5 by 6 is 5 by 6 only. So here, see, although so much is written, what is important is this numerator can be only 1 into 5. So we have kept only 1 and 5 as two possibilities. Whereas here it is 1 into 6, 2 into 3, 3 into 2, like that it can come. So 1 into 6 is not going to give us the required thing because so we will try to use the this is 2 into 3 here. So although we can have 1 by 2 and 1 by 3, can be sign can be positive or negative, 5 by 3 and 5 by 2. So if you want to check for P of half, it doesn't become 0. The first term is not becoming 0. But if we use this minus 1 by 3, it gives 0. So s plus 1 by 3 is a factor. Similarly, you have to try all other things by trial and error. So when you substitute 5 by 2, we are finding that the factor is 0. Maybe this will be more clear when you work out the problem. So let us take another example where Px is equal to 3x square plus 7x plus 4. Now split this 7 into two terms such that the product is equal to this coefficient of x square and the constant term. Product is equal to 12 and sum is equal to 7. Now, the 12 has got factors of 1 into 12, 2 into 6, 3 into 4. So next coming will be 4 into 3, 6 into 2, 12 into 1. So which is need not be taken because they are the same as these two. Now among these, it is necessary to see sum of which gives the coefficient of x in the, that is the middle term. So here select 3 and 4. So because 3 plus 4 is equal to 7 and 3 into 4 is equal to 12. So Px can be written as 3x square. Instead of 7x, we will write 3x plus 4x plus 4. Now Px is equal to, now you can take 3x common factor between the first two terms, giving x plus 1, 3x into x plus 1. Plus here take 4 as the common factor between the last two terms. That will also give x plus 1. So we can write it as x plus 1 into 3x plus 4. We can write it here as two factors. Now, when you substitute x is equal to minus 1, this first term will be 0 and therefore the result is 0. When you substitute x is equal to minus 4 by 3, the second term will give 0, therefore product will be 0. So x plus 1 and 3x plus 4 are factors of the given polynomial 3x square plus 3x plus 7x, 4x plus 4, or 3x square plus 7x plus 4. Now consider another example. Now here it is important to say that the letter in the as used as variable is changed to y. So our equation will be in terms of the variable y. So let p of y is equal to this given polynomial. Now, if this can be expressed as factors of 2, it will be like y minus a and y minus b. And constant term, that product AB must be equal to this 1 into 6, which is 6. So factors of 6 are 1, 2, and 3. Now select those vectors which will give sum as minus 5 and product as 6. So it is necessary to take so one method is check for all the three things. Find the value of the polynomial at x is equal to 1, at in this problem y is equal to 1, y is equal to 2, y is equal to 3. So by substituting 2 here, we'll get 2 square is 4, minus 5 into 2 is minus 10, and this is plus 6. So plus 6 and plus 4 and minus 10 becomes 0. So 2 is one suitable number. So the factor will be y minus 2 because y is the variable we have used here, and we have substituted y is equal to 2 in this polynomial to get the 0. Similarly, suppose we substitute 3 here, what happens? 3 square will be 9 minus 3 into 5 will be minus 15, and there is plus 6. So 6 and 9 will give 15, and this is minus 15, that is again 0. That means y is equal to 3 is also a 0 of this polynomial, a root of the polynomial equation. Px is equal to Py is equal to 0. That means y minus 3 is another factor. That means y minus a and y minus b, we have found the value of a and b. So it becomes y minus 2 into y minus 3. So P of y in this problem, the letter P of y is used because y is the variable used in the polynomial. Split this 5 into two terms such that their product is equal to 1 into 6 equal to 6. And sum is 5. Factors of 6 are 1 into 6 and 2 into 3 only. Because next we will find 3 into 2 and 6 into 1, which are same as this thing. Now select 2 and 3 because when we add, we can get 5, and 2 and 3 multiplied, we get 6 into this 1, which is equal to 6. Since coefficient of y square is 1, if we don't multiply by 1, it is okay. So we get the 6. Otherwise, as a general rule, you have to multiply the coefficient of y square and the constant term here to get the product of the two numbers which are used here, whose sum is this minus 5 and the product is 6. So the given polynomial can be written in this form. Is minus 5y can be split into minus 2y and minus 3y. Now between these two, take y common factor, it becomes y into y minus 2 minus, here between these two, take 6 as the common factor, you get y minus 2. Now y minus 2 taking common factor between these two, we get y minus 3 as another factor. Now if you substitute 2, this 0, therefore 0 into this will be 0. Similarly, if you put 3, this will give 0, so 0 into 0 will be 0. Now we'll try another problem. Factorize x cube minus 23x square plus 142x minus 120. Now, if you want to find which are the roots or factors of the given polynomial, one of the method is without application of mind, where no brain work is necessary and it is purely a mechanical application of method. Anybody can blindly use it. That is, we have found that in most of the problems we come across either in examples or in exercises or even in different examination question papers, one of the real root or zero of the given polynomial lies will be between minus 4 and plus 4 generally. So what we will do is, let us find what happens to the value of the polynomial when x is substituted by minus 4. So minus 4 whole cube will give minus 64. Minus 4 whole square will be 16. 16 into 23 multiplied will be 368. That minus sign will be here. Plus here we are substituting minus 4. So minus 4 into 142 will give minus 568. And this minus 120, write it as it is here. Now, when we simplify, we find that all numbers have negative sign only. Therefore, whatever we get is a negative number. We don't have to really calculate. That means if we substitute minus 3, minus 2, minus 1, again, all these things will be negative only. So it cannot become 0. So we will not substitute -3, -2, -1. So if we substitute x is equal to 0, then the first three terms will become 0 and we get the -120. So it is also not 0. Now we have to try what happens when we substitute p is equal to 1. When you substitute x is equal to 1. When you substitute x is equal to 1, 1 cube will be 1 minus 23 x square is minus 23 plus 142 x is plus 142 and minus 120. Now here this minus 120 and this minus 23 becomes minus 143 and 1 plus 142 is also 143. They cancel giving 0. That means 1 is a 0 of the given polynomial or x minus 1 is a factor of that. Actually, now we can stop. Further things is not required. One factor we have already found. But we can continue by trying to see p of 2 equal to what? If it is 2, x is substituted by 2. So 2 cube will be 8 there. 23x square will be 4 times of 23, which is 92. And this is again 2 times of 142 is 284 and minus 120. So these two added will cancel with 282, 84 plus 8. That is 292. Oh, it is not cancelling. Okay. So we will get 80. Now we have tried like other number, they are not cancelling. But continuing, you see 10 in right, it is becoming 0, 12 it is becoming 0. So actually, when we get one particular polynomial, the value of x for which the polynomial is 0, it is enough. So we don't have to continue this. But continuing like this, it is possible to find some other values of x for which the polynomial becomes 0. So the given polynomial is this one, p of 1 is equal to 0. That means x is equal to 1 is a root of px is equal to 0. This is called the polynomial equation. Or x minus 1 is a 0 of the polynomial that is given there. So taking this to left hand side, we get a factor. So x minus 1 is a factor of px. Now once we know x minus 1 is a factor of px, we can rewrite this given polynomial, which was x cube minus 23x square plus 142x minus 120 as x cube minus x square minus 22x square plus 142x minus 120, because to get x minus 1 as a factor, we have to have x square here, take x square common factor, we get x minus 1. So we will get x square into x minus 1, we will get there. Now this one to get the x minus 1 common factor, this 142, it is necessary to split into 22x plus 120x, so that the 22x can be taken as common factor here between them, and we get the x minus 1 as the factor. Plus here we take 120 as common factor and we get x minus 1. So this x minus 1, x minus 1, x minus 1, that is the common factor in the three terms. So taking x minus common factor, we get x square minus 22x plus 120. So y is equal to x square minus 22x plus 120. In this case, this 22x can be written as minus 10x and minus 12x because we want to get like x minus 1. So here we will get x common factor, you get x minus 10 minus here 12 if we take, we get x minus 10. So x minus 10 into x minus 12. So these are the other two factors. First one we found x minus 1. The second and third factors are this. So value of y when x is 10 is 0, value of y when x is 12 is also 0. Earlier we have found value of y when x is 1 is also 0. So x minus 1, x minus 10 and x minus 12 are factors of the given polynomial. Px is equal to x cube minus 23x square plus 142x minus 120. Now suppose we try p of 10, we find that it is 0. Therefore, x is equal to 10 is a root of given polynomial, or x minus 10 is a factor of px. Similarly, when you substitute x is equal to 12, we get x cube 23x squared 142x and minus 120. So simplifying, this again becomes 0. So x is equal to 12 is a root of the given polynomial equation. Px is equal to 0, or x minus 12 is a factor of the given polynomial. So we found that x minus 1 is a factor, x minus 10 is a factor, x minus 12 is a factor. Therefore, we can write Px is equal to x minus 1 into x minus 10 into x minus 12. So that is what is done here. Now, we have to work out the exercises given in the problem here, which use the ideas whatever we have learned in the present chapter. So determine which of the following polynomial has x plus 1 as a factor. So we have to just find out which polynomial has x minus 1 as a factor. That is, there are 4 problems. In all of them, we want to check whether x plus 1 is a polynomial, is a factor of this, is a factor of this, is a factor of this, or is a factor of this. So it can be done either by long division, dividing this by this one, or equating x plus 1 is equal to 0, so x equal to minus 1. And substituting here for x is equal to minus 1, simplifying, determining whether the answer is 0 or not. If we substitute x is equal to minus 1 and simplify, this polynomial value becomes 0, then this x plus 1 is a factor. So let us do by both the methods for practice. First, we will divide the given polynomial x cube minus 23x square plus 142x minus 120 by x minus 1. So here px is this given dividend or the given polynomial, gx is the divisor, which is x minus 1, and qx is the quotient obtained, and rx is the a remainder later that we are getting. So to get x cube here, multiply x by x square. Then same x square into minus 1 will give minus x square. So the first two terms will cancel. That is how we have selected this term in the quotient here, so that this when multiplied by this gives this first term. When I subtract, it becomes minus 22x square plus 142x minus 120. Now, to get minus 22x square, since there is x here, we have to multiply by minus 22x. So minus 22x into the x will give minus 22x square, plus minus 22x into 1 will give plus 22x. Subtracting these two will cancel, and when you subtract this, we get 120x minus 120. Now, if you multiply by 120 by x, we get this one, and 120 by minus 1 will give minus 120. So here, though we wanted to make this term 0 on subtraction, automatically it is also getting cancelled and remainder has become 0. Remainder 0 indicates that x minus 1 is a factor of this item, this polynomial. So alternatively, we can find the roots of the polynomial equation, say yx is equal to x square minus 20x plus 120, by using the formula, which is minus b plus minus root of b square minus 4ac by 2a. Here you can see this bracket is necessary to show, to give importance to the plus or minus sign of the number that is used. So this minus into minus becomes 22, the squaring becomes plus 484, and this one will give minus 480. So 484 minus 480 gives root 4, and that will become 2. So 22 plus or minus 2 will become, taking positive sign, 22 plus 2 by 2 and 22 minus 2 by 2. So this gives 24 by 2 and this gives 20 by 2, or 12 and 10. This is what we got earlier. So that means x minus 12 and x minus 10 are factors of the given polynomial. So earlier problem, Px was x minus 1 into this item was there, which has been further now got the factors. So we can write like this. This can be also written something like giving terms with ascending power of the constants. X minus 1 into x minus 10 into x minus 12 also we can write. So in this problem we found x plus 1 is a factor of this by long division. Same thing, by equating x plus 1 equal to 0, you get minus x is equal to minus 1. Substitute minus 1 whole cube, minus 1 whole square, minus 1 and plus 1. There also you find that it becomes 0. Similarly here, if we try to put x plus 1 is equal to 0 and x equal to minus 1, minus 1 will give plus 1 here, this is minus 1, they will cancel. This is plus 1, this is minus 1, they will cancel, and 1 will remain. So the value of the polynomial is not 0. So x plus 1 is not a factor. So try to do this by long division also for practice and getting experience in handling numbers with positive and negative signs. Here if we substitute again x equal to minus 1, this becomes plus 1, this becomes minus 3, this becomes plus 3, this becomes minus 3, and again 1 will remain there. Now this is plus 1. So it is plus 1, this will be minus 3, and this is plus 3, they will cancel. Here there was plus 1, there is minus 1 for this, so cancels, 1 remainder will remain. So therefore, x minus 1 is not a factor of this. So determine the this one factors by using long division also, just for practice. Now if you make x equal to minus 1 here, this will be minus 1 and this will be plus 1. This will be, but minus of minus will become minus 1 again. So minus 1, and this is also minus 1, and minus here x square say put x is equal to minus 1 here, you get minus 1, this is minus 1. So that is minus 2, and minus 2 will be minus 4, and this will be minus 1. So this will be plus 2, they will cancel, but there is plus root 2. Because x is minus 1, this will be plus root 2. This into this will give the minus, and this with minus 1 gives plus. So plus root 2 is not cancelling. So therefore, x plus 1 is not a factor of this. So try to do this by using long division also to show that remainder is 0 or not 0, as the case may be, for practice. So let us stop here and we'll continue in the next class. So please practice all the topics we have learned so far from beginning to end. Again, more than one time if necessary, so that you will become an expert in mathematics and you will be ready to become an eminent scientist, an eminent professor, an eminent engineer, an eminent innovator, as the case may be, so that it will be useful for you. So until then, goodbye. Good luck, viewers. Have a good day.